If you're watching the videos in order, in our last video, we saw that we thought the derivative of sine was cosine, and we thought the derivative of cosine is minus sine. For the purposes of this video, we're going to take that as a fact, that these are in fact true statements. Maybe you've gone on and watched the videos out of order, and you've watched the derivation, the proofs of these two facts, so you might be ahead and know that those in fact are true. But what I want to do now is use these two facts to deduce the rest of my trig function's derivatives. So we'll start with the derivative of tangent. And my options here are maybe to do something like I did with sine, cosine, I draw a picture. Or maybe I use the limit definition of derivative. But what I'm going to do instead is use my differentiation rules and some facts about my trig functions. See, I know a quotient identity. I know that tangent is the same thing as sine of x over cosine of x. So now I'm taking the derivative of a quotient, and I can use the quotient rule. The bottom gets squared. The bottom times the derivative of the top, and the derivative of sine is cosine, minus the top times the derivative of the bottom, and the derivative of cosine is minus sine. So on the bottom I have a cosine squared x, and at the top I have cosine squared x plus sine squared x. Well, this makes me very happy because that's the Pythagorean identity. My Pythagorean identity. Cosine squared plus sine squared is always equal to 1, so I get a 1 over cosine squared, which I'm going to rewrite using a reciprocal identity as secant squared x. So, coming back here, the derivative of tangent is secant squared. I want to think about that for a moment. We didn't start with a picture here, but I do always like to think about the graph of a function when I'm doing something. Tangent has asymptotes at pi halves and minus pi halves. And between that set of asymptotes, its graph looks like this. And what I would tell you about every single tangent line I ever drew is that they would all have a positive slope. They all go up from left to right. And when I look at secant squared, I have secant of x all squared. And I can promise you secant of x all squared is going to be a positive. This derivative has to be positive. And I can graph the rest of tangent just by copying that same period over and over and over again. So there's my derivative for tangent, and the graph even makes that make sense. I think it'd be a good idea for you to pause the video now and do what I did for tangent, but with cotangent. All right, so now that you have taken a second to find the derivative of cotangent, let's see how you did. Cotangent of x is cosine over sine. And I'm going to use the quotient rule. The bottom gets squared. The bottom times the derivative of the top minus the top times the derivative of the bottom minus sine squared x minus cosine squared x all over sine squared x. I'm going to factor out that minus. Gives me a sine squared x plus a cosine squared x. There's that nice happy Pythagorean identity again. So on the top I have 1, and a minus 1 at that, over a sine squared, which I'm going to rewrite as a minus cosecant squared x. And there's my derivative for cotangent. So again, let's think about the picture. Cotangent has asymptotes at 0 and pi, and then goes down from left to right. So if I looked at tangent lines, they should all have a negative slope. And that's what that's telling me. Minus 1 times a quantity squared that would be positive. All right, 2 more trig functions to go. Let's find the derivatives of cosecant and secant. One of the nice things about going through all these derivations is that it's basically just a good chance to practice using the quotient rule. All right, the bottom gets squared. And then I have the bottom times the derivative of the top minus the top times the derivative of the bottom. So here that would be 0 plus sine x. So I have sine x on the top and a cosine squared x on the bottom. Just going to do a little rearranging here. I have a cosine squared, which is just a cosine times a cosine. And so think about how to multiply fractions together. Those are the same quantity. 1 over cosine is secant. Sine over cosine is tangent. The derivative of secant is secant times tangent. And then finally, I need to find the derivative of cosecant. And again, I like the idea of y'all pausing the video and trying to do that one on your own. In fact, before you even do that one on your own, guess what it is just by looking at all the derivatives on the board, because I bet you could guess what the answer is. Okay, looking at what's on the board, I have sine's derivative being cosine, cosine's derivative being minus sine. The derivative of tangent is secant squared, and the derivative of cotangent is minus cosecant squared. I'm thinking that a minus and a bunch of cofunctions are involved. I think that's what my derivative is supposed to be. But I should do better than just thinking about it. Let's make sure. Cosecant is the same as 1 over sine. So I'm taking the derivative of 1 over sine. And again, I'm going to proceed using the quotient rule. The bottom gets squared. Then I have the bottom times the derivative of the top minus the top times the derivative of the bottom. All right, there's that minus sign we thought was going to happen. And then I have a 1 minus 1 over sine x times cosine x over sine x. It's a minus cosecant x cotangent x. So here I have listed the derivatives of all 6 of my trigonometric functions. Past this video, I need to actually prove these 2 statements because so far I've just kind of drawn pictures and waved my hands and said they were true. And I want to do more examples where we take derivatives of more complicated functions that involve trigonometric functions. But that's it for now.